Okay, so let's see how this new product rule works. Now, I'm gonna skip this. Let's go back to our original equation. Y equals x squared times the sine of x. And so we have a product and we want to find y prime. And so we're going to have to use this rule. Now you have to somehow remember the product rule and how it works. And so this is what I always think in my brain when I'm doing a product rule. I first determine which of my I label my functions. One is the first function and one is the second function. So f of x is my first, g of x is my second. Then I say the derivative of a product is f of x, which is my first, times the derivative of the second, which is g prime of x, plus g of x, which is my second, times the derivative of f of x, or my first. So I always say the first times the derivative of the second plus the second times the derivative of the first. So let me write that out. So the derivative of a product. Okay, I write the first times the derivative of the second plus the second times the derivative of the first. Alright, so the first times the derivative of the second plus the second times the derivative of the first. And when it comes to the product rule, it's actually fairly forgiving because, if you think about it, multiplication is commutative. So if I write x squared first and sine of x first, that's okay. But if I decide to switch it, because it is commutative, then sine of x would be first and x squared would be second. The big thing to remember is you do have to use this rule somehow. Okay, so let's go ahead and use our rule. We have, this is x squared, so I'm going to call this my first, and the sine of x is my second. And you don't have to identify which is first or second, I'm just doing it for this first example. After this, we'll never do that part. Okay, so let's take the derivative, y prime. So we have the first, which is f of x. So we just write it down again, x squared. And then we're going to multiply this by the derivative of the second. So the derivative of the sine is the cosine of x. Plus the second, well, we write down the second again, which is the sine of x, times the derivative of the first. The derivative of x squared is 2x. So notice how this matches our rule up here. Let's see if I can get this up here. We have f of x times g of x. This would be f of x, this would be g of x. And then the derivative is f of x, so we wrote it down again, times the derivative of g of x. Then we have g of x, we wrote g of x down again, times the derivative of f of x. So it matches this pattern. And so we can then say that y prime is x squared cosine of x plus 2x sine of x. And this is what we would put a box around. All right. Alright, so there's our first use of the product rule. Okay, so let's look at another example. Let's say we have y equals 3x minus 2x squared times 10x cubed plus 3. And we want to find y prime. Now in this case, there's actually two ways we could get this derivative. So let's look at both methods. So method 1 would be to use the product rule. Okay. Because in this case we have a function here, 3x minus 2x squared. We have a function here, 10x cubed plus 3, and they're being multiplied, so this is a product rule. So let me write this down again. Y equals 3x minus 2x squared times 10x cubed plus 3. Okay, so let's go through our product rule again. Y prime. So remember, we have the first, so we just write it down again. 3x minus 2x squared times the derivative of the second. Okay, so the derivative of 10x cubed is 30x squared, and the derivative of 3 is 0. So there we go. Then we're going to add on to this the second, which is 10x cubed plus 3, times the derivative of the first. So the derivative of 3x is just 3, and the derivative of a negative 2x squared is a negative 4x. Okay, there we go. So technically we have our derivative. Of course, you always want to, once you get your derivative, you want to try to simplify it as much as possible. So let's go ahead and do that. So y prime is going to be, let's see, 3x times 30x squared is 90x cubed, and negative 2x squared times 30x squared is a negative 60x to the fourth. These are binomials. So let's see here, 10x cubed times 3 is plus 30x cubed. 10x cubed times a negative 4x is a negative 40x to the fourth. 3 times 3 is 9. And 3 times a negative 4x is a minus 12x. And so let's see here, we end up with the y prime being, let's see, negative 60 minus 40 is a negative 100 x to the fourth. Let's see, we have 90 and 30x cubed gives us a plus 120. It's a big 2, but x cubed. Let's see here. We have a minus 12x plus 9. And so there is our simplified version of the derivative. Okay, so now let's look at another way to find this derivative in this particular case. And so method 2, we've talked about this a number of times, is to rewrite. So if we start off with y equals 3x minus 2x squared times 10x cubed plus 3, the first thing we're going to do is, why don't we multiply these two binomials together? So let's see here, 3x times 10x cubed, that is 30x to the fourth. 3x times 3 is plus 9x. And negative 2x squared times 10x cubed, wait, that's a negative 20x to the fifth. And then a negative 2x squared times 3 is a negative 6x squared. Okay, so let's rewrite this so it's in standard form. We have a negative 20x to the fifth plus 30x to the fourth minus 6x squared plus 9x. And so when we take the derivative, okay, so a negative 20x to the fifth, so negative 20 times 5 is a negative 100x to the fourth. Okay, then 30 times 4 is 120x cubed. Negative 6 times 2 is a negative 12x plus 9. And notice, this is the exact same answer as this. So we do end up with the same answer. So I wanted to go through this process here because what's going to start happening in calculus, especially as we get more rules and we start working with different equations, is a lot of times there are going to be two ways to solve something, which in a lot of ways is neat. But sometimes it can be frustrating because if you choose one way, it might not be as efficient as another way. In this particular case, I think which way you chose was fairly harmless. It looked like it took us 1, 2, 3 steps, 1, 2, 3 steps, so both of them worked pretty well. And one wasn't significantly longer than the other. But I just kind of wanted to point out that oftentimes in calculus, there are different ways to get to the same answer, and so just because one person does it one way and another person does it another way, it doesn't mean that either person is wrong. It's just, you do end up with the same answer. Now, of course, we do have to note that this just happened to work because we had two polynomials being multiplied. If I go back to this example here, x squared times the sine of x, there's no way to rewrite that. So for this case, you only had one choice. You had to use the product rule. So there are often times where there isn't more than one way to go. This is what you're given and you have to go from there. So in this video, we derived the product formula, the product rule, and so we ended up with this. And then we used that product rule to find some derivatives. And after a little bit of practice, you'll get pretty good at finding the product. But remember, even to this day, when I take the derivative of a product, I'm just thinking this in my brain. It's the first times the derivative of the second plus the second times the derivative of the first. It's a good way to look at the product rule.